Hi everyone and welcome. In this video we will see how we can read the floating point values of our Modbus TCP device in the Node-RED. Okay, so I have created a flow for four types of floating point values. If I can open my flow, then you can see here I have created a for function for four type of floating point values. Okay, the first type is 32-bit float, which is a Little-Endian Byte Swap type of floating points, and which is also called least significant register first. Okay, second one is 32-bit float, Big-Endian, and most significant register first. Third one is 64-bit float. Okay, so this first two is 32-bit of float kind of values. The second two is 64-bit of float values. Okay, so 64-bit float, double float, which is also called double float, and type is Big-Endian, and most significant register first. And the last one is 64-bit of floating point values, which we also call double float, and it's a kind of Little-Endian Byte Swap, and which is least significant register first. Okay, so if I open my mode scan here, and you can see in the setup, if you go to display option and you can go to double float, then we have two kind of option: most significant register first and least significant register first. Okay, so if double float is there, okay, so it means 64-bit of float values. Okay, and MSRF is a most significant register first. So if I want to read this kind of value in the Node-RED, then I have to use this function. Okay, and if I again go to setup, and if I go to double float, and if I select least significant register first, okay, then I have to use this kind of function. Display option is also available here. If you hover the mouse, then you can see double MSRF and double LSRF. Okay, LSRF stands for least significant register first, and MSRF stands for most significant register first. Okay, so if you click on display option, and so in the double float we have a two option, and in the floating point also we have two option, MSRF and LSRF. So for the floating point, which is 32-bit of float values, and in that also we have two option, MSRF and LSRF, which is most significant register first and least significant register first. Okay, so we will start with the first one. If we want to read 32-bit float, okay, a Little-Endian Byte Swap and least significant register first, then we have to use this function in the Node-RED. And let me set up in the mode scan. So we have to select floating point and we have to select LSRF. Okay, so you can see 32-bit float. Because of that, only two integer values will be occupied. In the 64-bit of float, four integer values will be occupied. Okay, now if I connect my mode scan to my Modbus TCP server, then you can see every value is 0. You can also see the value is 0. Now we know that it's a float, 32-bit float, and it's a LSRF. So if I write something here like 50.5, then you can see it is only valid for this. 50.5 is available here for this function only. Okay, for this three function the value is different. So if you want to read 32-bit of float values, Little-Endian Byte Swap, and least significant register first, then you have to use this kind of function. Now we are reading the same 32-bit float with Big-Endian type and with the MSRF, most significant register first. So I can click here. Okay, yeah, you can see float MSRF. If I click here, then value got changed because Big-Endian and Little-Endian has a difference. Okay, so that is why value got changed. So if I want to write here 55.5, I have done it, and I want to read that in the Node-RED, then you can see I can use this function to read this value. Okay, so if your Modbus TCP device is providing floating point values in this format, okay, Big-Endian MSRF 32-bit float, then you can use this function to read those value. If your Modbus TCP device is providing value in the 32-bit float, Little-Endian Byte Swap, and LSRF, then you can use this function. Then only you will get the proper value. And if it is MSRF, then you have to use this function. Okay, then only you will get the correct value. Now let's talk about the 64-bit of float values, which is we call double float, and there are, I mean, people can say Big-Endian or MSRF, Little-Endian or LSRF. Okay, now if I go to setup again, and here also you can change the type, display type, MSRF or LSRF. So we will first see for MSRF. Okay, Right now let me change the value to 0 here. Okay, you can see everything is 0. Now here I want to write 500 or 5005.5. Okay, so it is only valid, or it is only displaying in this function output. Okay, if I change to 6000.5, okay, you can see it is okay. I write 600, let me write 6000.5. Okay, it is only valid for these things. Okay, I have to use this function to get proper value. If I change the display option to double float LSRF, okay, then it will not valid, or you will not see any proper value. If I change the value to again 5500.5, then you can only see the proper value here. Okay, so if you want to read floating point values of your Modbus TCP device, okay, and if you want to correctly convert those value in the node rate, then you have to use this kind of function. You can get this node rate flow in the description of this video. Okay, it will be the paid node rate flow. You can buy this from our store. Okay, but it will help you to convert your integer data into the floating point data. Okay, now let me cover one more thing. If I go to display option, if I go to floating point, and if I go to LSRF, and if I write 50 here, okay, 50.5 here, then you can see the integer values. Let me write 0 here. Okay, you can see the first holding register has a value of 0, and the second holding register has a value of 16970. You can also see that here 0 and 16970. Okay, now if I make it a 0, then also you can see here okay. Now if I change back to MSRF, okay, float 32-bit float MSRF, and if I change the value to 50.5 here, then you can see the holding register value got changed 16970, and then second holding register has a 0 value. Okay, you got it. Now if I change to display option and double float and MSRF, and if I set it to 0, you can see every holding register value is 0. Here also it is 0. Now if I change to 5555.5, yeah, you can see here as well 5555.5. You can see the values of holding register here. Okay, now if I change option to LSRF, and if I write 0 here, it will turn to 0, and you can see every holding register value is 0. Now it is LSRF, right? Yeah, LSRF. And if I want to write 5555.5, and if I update it, you can see 5555.5 is available here, and those things are available here. Okay, so in this function I have I am reading those holding register. Okay, I am reading this 4 holding register in this function, and then I am converting those 4 holding register into the floating point values. Okay, so if I do this 5555.5, then I am reading this 4 holding register in this function, and then I am converting into the actual 4 floating point values. So same for this 2 functions as well. Okay, so I hope this thing is clear, that it is possible to convert your integer values to floating point values in the node RED, and you can use this kind of functions. Okay, you will get this flow in the description of this video, and if you still have any question or doubt, then you can ping me on WhatsApp, Telegram, Instagram, anywhere. Okay, so I hope this thing is clear. So we will meet you in the next video, and in the next video we will see how we can write floating point values. Okay, right now we are just reading the floating point values from our Modbus TCP device, which I have simulated using the Modbus slave software. Okay, but I want to write from the node RED. Okay, if I create some GUI, okay, and if I want to write 50.5 value from the GUI to my Modbus TCP device, then I have to convert that value into the integer values. Okay, so you can see if I want to write 50.5, okay, I want to write 50.5, in the MSRF format, Big-Endian, then I have to convert 50.5 into this kind of format. Okay, 16970 and 0. So I have to convert 50.5 into this format, and then I can write to my Modbus TCP device. Correct? And for that we need to create one more function, just like this, which has an input of float and which is providing output as a integer values in this kind of format. Okay, so I hope this thing is clear, and we will see that in the next video. So we will meet you in the next video. Till then, take care, goodbye, and thank you.